Hi everybody, my name's Gulley. Thanks for joining this afternoon. I'm a technical specialist with our Autodesk simulation team, focusing primarily on our FEA and CFD products. So thanks for joining us. There is a Q&A window throughout this presentation if you do have questions. I've got a number of my colleagues from product development and simulation business development over, and also as well as a few other technical specialists in the queue ready to answer your questions. So you're muted, but feel free to leverage that Q&A window to ask any questions that you may have. And so today what we're going to do is we're going to talk about going forward. So I'm sure a number of you were on the first webinar that we covered regarding the end of life of simulation mechanical and the end of sales of sim mechanical and what that meant for us. And so what we're going to focus on today is going past those details. We'll look at Nastran In-CAD in depth for you simulation mechanical users. So the overall agenda today is, like I said, a continuation from the first webinar on April 27th. And specifically what we'll do is we'll take a look at simulation mechanical. Going forward, what options do you have available to you? And what can you do to obtain those different accesses and different options? I'll make sure I cover that in depth today throughout this webinar. And what I really want to focus on is the similarities between simulation mechanical and Nastran In-CAD. As a technical specialist, I receive a number of inquiries each week requesting information on the capabilities of Nastran. And so, I want to focus on what's similar because they're very similar, and I want to be able to show you that. So we'll go in that in a little bit of depth and what capabilities and study types are accessible to us in Nastran. And then it wouldn't be a webinar if I didn't do some sort of demo. So I wanted to highlight some of the advanced analysis capabilities that we have within Nastran. And so specifically what we'll do is we'll focus on some of the nonlinearities that we have in Nastran, as well as the popular Composites tool for composites analysis that we have as well. Now, one additional benefit that we're going to have, or a few additional benefits we'll have, being inside of a CAD-integrated environment is the ability to leverage that CAD information up front to be able to utilize simulation information to help us create better design. So I also want to make sure that we're focusing on that as well. And then provide you additional details on upcoming webinars and where we can find more information. So let's talk a little bit about the Autodesk vision and the guiding principles of the Autodesk vision. And so Autodesk is keen on defining the landscape of FEA adoption and usage in the FEA, in the manufacturing community. So, our research into the need and use of FEA in manufacturing clearly shows that manufacturing community is increasingly adopting FEA, and the EDU community as well also uses FEA as a part of their core curriculum. And so by balancing versatility and comprehensive technology with advancements like cloud computing and generative design and optimization techniques, we are keen to set the pace for the prolific usage of FEA for rapidly emerging needs. And so this philosophy is generally recognized and defined by most solution providers in this space, as well as by renowned independent adversaries like NAFEMS. And so to do so, we have made systematic and intentional investments in technologies over the past few years, getting both industry credible and robust solvers, advanced materials technologies, as well as advanced explicit codes and synthesis methods. We have set ourselves the goal of bringing all these in a consumable fashion to a company like yours, as well as the broad manufacturing community. And so to be clear, this does not mean a divest from pushing into high-end technology, but rather revamp the delivery mechanism carefully so that there is a controlled approach to leveraging the technology for everyone's benefit. And so obviously it would be rash to put the high-end technology into the hand of novices and vice versa. So that is a necessary part of our direction. We have identified as a company two paths to delivering the next generation experience. One that is more traditional through a desktop-based workflow, And the second, that is intentionally disruptive, built on the cloud. Both are already mature in their own ways and for certain applications. And our goal today is to spend time on the desktop-based workflow, that is Nastran In-CAD. And on June 14th, for the third or for the third webinar of this series, for our simulation mechanical users, we'll focus on Fusion 360 and the cloud-based workflows that are offered. So with that being said, let's go ahead and let's jump in a little bit now that you understand a little bit more about our vision as a company. And so, as of March this past year, or this current year, we ended the simulation mechanical sales. So there are no new sales for simulation mechanical. A lot of this information was on the very first webinar, so I'm briefly going to touch on this, and I'm going to focus more today on the specifics of Nastran. What you should know is that for you simulation mechanical users that are continuing to use the software, while we also are offering no new sales, we are continuing the support of such. And what we've done for the SimMech users is we've offered Fusion 360 Ultimate to you to use, and that's going to include 1,000 cloud credits for this year. So I'll have some instruction for you at the end of this webinar on how you can obtain accesses and get information on how to proceed using Nastran In-CAD and how to use the Fusion 360 tool. And so moving forward, like I said, or I was alluding to just a few moments ago, we have two products that we're going to specifically look at for the direction of the future at Autodesk within the FEA realm. Fusion 360 is the cloud-based generation tool for FEA use. It's going to cover a lot of the workflows that you would have in Sim Mechanical, but it's not going to cover all of those functionalities. There will be some key differentiators, and we're going to go over these a lot in the next webinar. There's a lot of great enhancements that the team has put into this software as that next generation solution, like an event simulation, shape optimization, very futuristic technologies, very good for our customers to have. Those tools were not available with simulation mechanical. And today we're going to focus on Autodesk Nastran In-CAD, which is our desktop CAD integrated FEA product. It works inside of Inventor. It also plugs into SolidWorks. And for those of you that aren't using one of these pieces of CAD, I've got some information in an upcoming slide that will give you some direction on how you can proceed to use our tools also. What you'll notice today about Nastran is that it has very similar workflows to simulation mechanical. It's going to have more than what Fusion 360 would be. Obviously, there are going to be some exceptions, but you're going to notice that there will be no loss of technology for you. You are going to be able to continue the day in and day out functionalities that you are using in simulation mechanical. You'll be able to continue to use those in Nastran. One of the benefits of the Nastran tool is that it is a multi-user subscription. So that is a floating license that can be used across the network. And so there is no additional fee for that. Everybody can feel free to use that. So we're focusing on the scalability of our Nastran tool. And if you think about the word Nastran, right? Nastran itself is a very common name throughout the industry. This was used to back in the the 60s in the space program. And so because it's been around for so long, we have plenty of NAFEMS benchmarks to validate the accuracy of our code for multiple types of problems. And we have advanced types of analysis capabilities that we bring along for the ride with Autodesk Nastran. And we'll take a look at some of these today. A lot of these advanced type of non-linearities that we have that we can solve for inside of Nastran. And I think really focusing on some of the advanced dynamics and the ability to use composites analysis inside of Nastran as well. And as I mentioned a second ago, we definitely want to make it scalable and definitely put it in the hands of as many people in your company as we can, so we can help you make better products. So with that being said, let's take a look at some of the Nastran In-CAD capabilities. Now, in the left-hand column, these types of analyses are in almost every FEA package you would find. And a lot of you are probably completing nearly all of these, if not some of these. You know, things like, hey, just a basic static analysis. How strong is my design? You know, how long is that going to last over a number of cycles if I repeat this load? And maybe you're concerned with warranty issues and things like that. How long is it going to last? It's a fatigue type study. What are the critical frequencies? And then you've got, you know, what are the critical buckling loads? And we can also get into the heat transfer capabilities. But I want to focus more on the advanced analysis types that are going to be accessible inside of Nastran. So like I said, the ones on the left, those are nearly everything. Let's focus on what we can do in the more advanced realms. So nonlinear, we can handle all three types of nonlinearities. There's three types of nonlinearities in finite element analysis. There are nonlinear materials, there is nonlinear contact, and then there's also nonlinear geometry. And so I've got a slide later on where we'll touch on the nonlinear capabilities that will be accessible to you. One of the big analysis types that I run into often is in the transient domain. And when I say transient, I mean what is changing with time? What happens with time? Are my results changing with time? Is the load changing with time? We can identify the performance of our structure as a function of time. And that's very beneficial for us to be able to understand the critical behavior for our design. And with the new disruptors in the market, like 3D printing, composites has really come along the way. And it's one of the biggest benefits that is going to be within inside of Nastran In-CAD. Asking ourselves the question of, where am I failing in this specific composite? You know, is it a ply layup or is it a sandwich type of structure? You know, where am I failing? And being able to identify those areas is also critical for us to be able to make robust designs for those of you that are using composites. So I'll touch on that as well. We also have different frequency response or linear dynamic calculations like shaker table or random vibration, as well as a drop test. So in summary, right, we have a ton of different capabilities that are available to us inside of Nastran. The linear types that we've been able to handle in every code are still going to be there, but I wanted you guys to know that we also have these advanced analysis types as well. So those advanced analysis capabilities that were in simulation mechanical are going to be right here available to us. And so what I did is I took a couple screen grabs from the simulation mechanical menus and also the Nastran menus, and I wanted to lay these up. And so while they might be named different things, it's the same stuff. It just has a different name. And the reason it has a different name is because of the Nastran solver. It's just different. So we name it something different. I've color coordinated, right? So the purple box up here, right? If you go up here to the top, all the linear models are still the same. A nonlinear static model is a nonlinear static model. That's still the same. A nonlinear transient response is your MES with nonlinear material models. That's still the same. As well as frequency-based calculations that I was talking about just a second ago. Those would be in the orange box. So we've got a couple of different naming conventions just because of the solver calls them out differently, but it's the same type of stuff. And so what we've done as a company, and the development team, you've got to put your hats off to them. They've done a tremendous job enhancing Nastran In-CAD. So if there were gaps between the functionality of the software, between Nastran and simulation mechanical, what we've done is the development team has worked hard to close these gaps, and we've done that in this year's release of Nastran In-CAD. The first one is fluid structure interaction. We now have the ability to take loads from our computational fluid dynamics study and bring them over to a structural analysis. So if we're doing a temperature type load where I need to bring the temperature gradients over, so I need to analyze the thermal deflections as a result of temperature or as a function of temperature, I have the ability to do that. Or if I have some sort of wind loading where I want to bring the pressure information over to my structural mesh and bring that in as a boundary condition, we now have the ability to do that one-way FSI. So that gap is now closed. Also, the development team has worked on creating a response spectrum analysis. This is very, very popular for time history loading. A couple of examples, we'll call them out here. earthquakes, wind and wave loads, and some vibration, right, where we might have some accelerometer data, some information. We want to focus on peak responses. So we've brought that information over, and we're trying our best to close that gap. Now, a lot of you are probably asking yourself right now, well, hey, you know what? I don't design in Inventor, or, I don't design in SolidWorks, and that's fine. As it stands right now, Nastran In-CAD is an add-in to both Inventor and SolidWorks. But with the acquisition of AnyCAD and bringing that into the Inventor portfolio, those of you that are not using one of those main CAD tools, that's fine. With the addition of AnyCAD, we have the ability to bring in a CAD file without making it just a dummy body. And so what I mean by that is we can create associative relationships from the parent CAD program. So hypothetically, let's say that you're designing in CATIA, right? And CATIA is your main CAD source. You can continue to design in CATIA, and then you can have those changes and that intelligence in the model stream down all the way to Inventor, so we can have it update our files. So if someone is changing the model and you want to create that intelligent link between the two, we can have that information reflect. And so therefore, any sort of analysis that we're doing inside of Nastran, we don't have to worry so much about the translation issues anymore, or not having that single source of truth, because AnyCAD is fixing that for us. So that's an exciting piece of technology that we've brought into the portfolio here at Autodesk. So let's start to talk about some of the advanced functionalities that we have available to us. And so I like to take a few steps back and look at a fundamental level of a nonlinear type of analysis. And so from a fundamental standpoint, we really have three types of nonlinearities. There's a material nonlinearity, a contact nonlinearity, and a geometric nonlinearity. And so I want to touch on all of these and let you know that Nastran is capable of handling each one of these nonlinearities. So from a nonlinear material standpoint, what I mean by nonlinear material is it doesn't follow a standard stress strain curve. And so if you look over here to the curve on the right-hand side, many of you are familiar with this stress strain curve. An example of a nonlinear material is not going to follow a standard stress strain curve. It's going to be nonlinear in nature. In fact, if you looked over at the left-hand portion of the curve, you'll notice it's straight, it's linear. This is like a metallic of some sort. Something that's rubber is maybe all over the place. So I like to think of a nonlinear material as like a rubber band, right? It's something that I can take, I can stretch it as much as I want, and while it has that high strain, it exhibits very low stress. And so we can also, inside of Nastran, model hyperelastic materials that exhibit such behavior, and we have multiple material models that enable us to do that. So that we also have some exciting capabilities there. The other would be a nonlinear contact. This is where we have changes in the stiffness of the contact as two bodies are coming into contact with one another, and they start to move around. So as two bodies in an FEA program come into contact, they have a change in stiffness. And so this is an example of maybe a sliding contact where you have two gears that are rotating around, and the teeth come into contact and they start to slide off one another. That's a nonlinear type contact problem. That change in stiffness is definitely going to be reflected in the solver matrix, and it's something we can do in terms of nonlinear contact in Nastran. A nonlinear geometry, this is your material hardening type of nonlinear analysis, or your strain hardening example. For example, once we pass the yield point, we are starting to strain harden, where that curve becomes nonlinear in nature. And so we need our FEA codes to be able to model that type of behavior. And so we have plasticity models that we can handle as well. So if you're concerned with things like, what is the plastic deformation once I start strain hardening, we're going to be able to attack those types of problems inside of Nastran. These are also your large displacement type problems, like a trampoline stretching. And To over-exaggerate, not saying we can do this at all, but a car crash would be another example of such. So with that being said, let's take a look at a quick demonstration of an advanced analysis type inside of Nastran. And so what we're going to look at is a shock load or a nonlinear transient type of analysis of a landing gear. And essentially what we're going to do is we're going to say that the landing gear is out, and all of a sudden we hit a big bump of turbulence. When we model something statically, what we're doing is we're saying we're applying that load very slowly. In order for me to be able to apply a shock load, I need to be able to change the load versus time. So you're going to see inside of this quick demonstration how I can go in, I can change the loads versus time. I can look throughout the life of the quick cyclical behavior of this analysis and target in on those times where I might be needing to identify specific behavior. So the first thing that we do, you'll notice on the left-hand side, we've got different materials that we're going to assign to this. So what we do is we leverage that geometry and we assign a material to that. If we're going to go into the realm of nonlinear materials, you'll see a little tab down there called nonlinear. If we were to look at plasticity in our model as a result of loading, that's where we would go. Once I have the materials assigned to the body, all the loading conditions is what we have to set up next. And so instead of just applying a standard load, what I'm going to do is I'm going to pick from our drop-down menu where I have a number of tools accessible to me in terms of load, and then I can plot this transiently. So I can look at a scale factor versus physical time. And so this is just going to be gravity, and we're just going to shock our system with a sawtooth waveform, and we're going to let the system damp out once we reach that peak value. So we're going to hit it with about 10 to 15 Gs in about 10 milliseconds, so a quick ramp. And it wouldn't be dynamic if we didn't have the ability to go in and turn on damping. And so I left damping pretty low for this quick example. It's around 1%. So the system doesn't actually dampen out, but just to show you the cyclical behavior of that load. We also need to define how long this is going to last. And one of the things we can do is we can also turn on a skip factor. This is going to enable me to save every 10 steps out of every step I calculate. Beneficial for you so that you can save your disk space. And once I've run the analysis, because I've run this versus time, I can pick a specific instance where I want to view the behavior. So let's say I've targeted in on a region that maybe a high displacement time in my analysis. I can look at the displacement result, and I can create an animation and view that. And a few versions ago of Nastran, we also created these quick drop downs, making it very accessible for me to change the analysis parameter I want to look at. So going from a displacement result, without going up to too many menus, I can quickly go in and look at some stress behavior and analyze that situation. I think the most important aspect of FEA, or one of the most critical aspects of FEA, I should say, is the ability to animate our analysis. This is critical for us so that we can analyze how the structure likes to move over time. So in a situation like this one where we're analyzing throughout time, I can plot that time behavior and truly understand how my structure likes to resonate. And so I've got a major spike on the first load, and then eventually my system is going to start to dampen. We can also create these XY plots, and so this is going to give me some quantitative analysis on the results versus time. So I'm looking at a total displacement versus time for a specific node. We can also leverage that information and analyze it further by exporting that information out to a text file and take it to Excel. In that particular output, I noticed one problematic time step that was giving us an issue. And so what we can do is we can go in and identify the behavior at that particular instance. Let's take a look at another example. This is a random vibration example. So let's say our landing gear is out, and it's subject to random vibration. And so what I mean by this is our loading is not determinate. It's not definite. It's actually random in nature. And so it's actually, it's statistical in nature that we define that type of load. One of the benefits is being able to duplicate a study so I don't have to recreate any information. And what I'll do is I'll define a modal output and say I want to extract the last 10 frequencies or the first 10 frequencies. Again, we have the ability to turn on the damping so we can correctly model this vibration behavior. And I have worked with a number of tools over the year. This is extremely friendly. I can go in, I can add a PSD curve, which is just your statistical probability of the loading versus frequency, so just magnitude versus frequency. Go out to Mill Standard 810, you can pull down this curve. This wasn't for a specific application, but we're able to capture the true dynamic behavior because I can also spread calculations around the modes. So I can ensure that I'm capturing the dynamic effects without having to guess the time step and then start refining from there. Once I output, I can look at a frequency versus mode number to get an idea of the frequencies that I'm outputting. And then I can also look at the peak frequencies and their responses as I'm looking at a max displacement magnitude versus magnitude frequency plot, which is automatically calculated for me. So after you read that plot, you can take this information, go in just like you could in simulation mechanical, right? Find that problem time step, plot that, and it's all about, at the end of the day, we're retrieving some information about our designs. We're taking it back to our design in the first place, making the correct changes based off this information to help you create more robust and better and overall better designs. You can also leverage this box where you can create, or there's this pop-out window, I should say, where you can create multiple analysis types as well. So I've only focused really on the stress and displacement. There are a number of capabilities inside of the window here, but it would be physically impossible within this 45 minutes for me to be able to teach you all that. But there's a lot of advanced capabilities inside of there. One of the analysis types that I think myself and the team has come across a lot lately is composites analysis. A lot of industries are focusing on lightweighting their components, so we've seen an increase in composites use, especially with the increase in materials technology that we have out there. And so we're happy to announce that we do have a composites analysis tool that provides you value so that you can identify the behavior of composites. So you can look at a composite as a single layer to maybe identify a problem layer, or you can identify the composite as an entire stack. So whether you're working with a ply layup or a sandwich type composite, we can certainly have you handled there. And we can take the information, and we have ways that we can understand the fiber strength and the adhesion strengths as well. What you'll notice in the menu off to the side is this is the standard layup tool for us inside of Nastran. And all we have to do is we define a particular material, or we can use one from our database if it exists, or you can create your own material if you want to input that into the system. And what we have to specify is the thickness of that particular ply or that sandwich, and then specify the orientation of those fibers. And we're able to create as many plies as we want. I'm not sure if there's a limitation or not that might pop up in the Q&A, but we can certainly go in and analyze the laminate by just using a single shell element. And so a quick example, that would be a 3-point bend test. This is a very common test for evaluating the strengths of composites. This is actually a nonlinear transient type of analysis. That rod that you see is slamming into this body at about 50 miles an hour. And so this composite, at the end of the day, is deflecting largely, so it carries over some of those advanced nonlinearities. But also we have the ability to go in after this thing is loaded throughout time and say, where does the composite have issues? Which specific layer is giving us problems? Maybe there's something we can do there. Do I need to change the orientation of it in the stack? Do I need to rotate that around? What can I do to increase the overall strength there? And so we can leverage information from our Composites tool to help us lightweight and build better composites. There were a lot of questions in the Q&A window last week about meshing, and so I want to make sure I cover some meshing information. The first thing I want to point out before I even get into the capabilities is you always have to analyze the fidelity of the mesh regardless of the tool, right? You always have to make sure that the mesh is good and it's feasible, and you're going to be able to get some good results from that. That's never going to change, or that may change, but it's not going to change right now. We have to make sure that regardless of the tool we're using, we're still looking at the mesh. It's our due diligence as analysts, as designers and engineers, that we're looking at the mesh and making sure it can give me some good results. So with that being said, what type of capabilities do we have within the mesh? I've used a number of FEA tools over the year, and I'm very satisfied with the solution that we have inside of Nastran. And so we have automated meshing capabilities that are going to allow me to put some mesh on very quickly. And so I've noticed a trend with the meshing. And so, you know, before, you know, even in the days of my, when I was on the other side of the table working in industry, I would spend a lot of time building these manual meshes, and it would take, you know, I would always often pride myself, right, that it would take me so long and I would put so much work into it. But at the end of the day, it's really just a means to an end, right? I want to be able to get some good results and be able to take that information and create, you know, better designs. Or in my case, as an analyst, I want to be able to help my engineers make better designs. And so inside of the automated meshing capabilities, we have solid TET elements. We also have shells. We have quads and tris for those shell elements. So enabling you, for those of you that are doing a lot of sheet metal and thin member analysis, we have the ability to use shell elements. And then if you're using frame structures, we also have beam elements or line elements that we can cover. I think one of the advanced capabilities of the Nastran tool itself is the slave master node. And you may often hear this referred to as a spider web, where we're controlling a master node and it's dictating its actions over to the slave so that we can get that specific type of behavior. And because of that, we also have different types of connectors that we can bring in as well. We're past the days of having to mesh different bolts and things like this inside of our analysis. We can speed up that process for you by creating bolt connectors, rigid connectors, springs, and pins, so that we can characterize that and get faster runs for us without the need to model that information. I should also note that outside of a global mesh, while it may be automated, you still have the ability to go in and create local mesh controls. So if you need refinement in a particular area, or if you need to look at convergence issues in a particular area, you can go in and you can create your own mesh controls in specific regions so that we can correctly capture that behavior. And this is all just tying back to my note of you always have to have a good mesh, or, you know, we have to analyze the fidelity of that mesh regardless of what we're using. There are some additional added benefits to being in a CAD tool for those of you that you may have not had with simulation mechanical. And so with the frame automation inside of the in-CAD tool, what we can do is we can quickly take the metadata from frame generator and export that over to Nastran. And so what that's going to do is it's going to pull all of the cross sections and all the inertial information and all those properties over for me, so I don't have to input that information into the system. It's done automatically for me. So quick example here with the frame, I've got a quick shell, thin member on top. And this is a great example of a hybrid mesh where we have multiple element types coming together. I've got the frame and line elements on the bottom, and then I've got a shell on top. And we can have these different element types still talk to one another. So if we're going to take this diving board example and we're going to load it up, this cantilever beam, right, my elements can still talk back and forth, right? So there is some information there that's brought over automatically. The benefit of using these element types is the fact that I get some quick run results. And so once I've run the analysis, I could still go in and I can look at the results inside of my shell. And then I can also take a look at the overall frame itself and see where I may want to go in and apply some different types of members if I'm going to strengthen or take weight out of my overall structure. This is probably one of my favorite tools to use, is the fact that I can automatically idealize thin member bodies in Nastran. So I can automatically find these thin member bodies, and it's going to create mid surfaces automatically for me. It's amazing. So I can go in, I can get the mid surfaces extracted, and then I can work with those surfaces only. No need to go into a tool and offset surfaces or go in and manually create shell elements yourself. We can automatically have Nastran create this information for us. So we have a quick time saver there that's going to be really efficient in order for us to be able to map out our loads and our analysis. So once we've set that up, right, it's applying our loads and applying our constraints, and then being able to go in, run the analysis, and look at our results. So there's a lot of added benefit to being inside of the CAD package, and I think the frame generator and the fact that we can quickly idealize that information, as well as finding these thin member bodies, is going to be benefits that you have available to you now inside of Nastran. The last thing I'll leave you with in terms of capabilities with the CAD is the optimization benefits leveraging Inventor. So Shape Generator is definitely making its way through the market. It's becoming a very popular tool for us. And so this is just a word for, or phrase for topology optimization. And so with topology optimization or Shape Generator, what we're able to do is we're able to maximize the stiffness of our part and be able to reduce the overall amount of weight. So we can specify a weight, and then we can target in on increasing the overall stiffness of our design. And so what we can do with this information is we can figure out what a design, once we lightweight it, is we can export that over to Nastran, and I can analyze this type of structure for additional stresses and strains. We also have parametric optimization. This is a what-if type of analysis. This has been out for a while, but this gives you the ability to change CAD-related dimensions, whether it's a thickness of some component or a height of some component, and basically say, hey, what if I start changing this geometric information or this material? What does that do for me? How much money can I save by changing these things? What can I do to create a more robust design? So ideally what we can do, right, is we can test out a number of different scenarios, pick the best one, and then export that information over to Nastran. So you're going to have a lot of benefit to you inside of Inventor that I'm telling you, you don't have available to you inside of Simulation Mechanical today, and that should be very, very exciting. We do have a number of resources for Nastran. It's going to have the online help system. We have the tutorials and self-paced training. I'll tell you what, as soon as I came onto Autodesk and I started to pick up this tool, it was easy for me to go up into the menus, hit the help key on a particular function, and then find out more about it. There's a lot of documentation built into the software that's going to help us become more efficient as well. So in summary for the Nastran In-CAD, the big thing about it, right, is that though you may have been using Simulation Mechanical, the capabilities are still there, right? The Nastran name itself is different, and so it's going to have a different name for these different types of technologies. But we're sitting inside of that comprehensive CAD integrated environment. And the benefit to you is the fact that you should never have to leave that environment. You can take the information that you have, right, and you can update your designs. Or if you're an analyst and you're on the other side of the spectrum, you can take that information and feed it back to your designers, right? It's all right there. It's not going to take me months to set something up, or high into weeks to get something set up and run it. right? So there's a lot of benefit for me to do that. And we're continuing to enhance the tools that we have, and also focus on the additional functionality like the shape generator, like the different optimization tools and the automation to help you out at the end of the day. So Fusion Simulation is going to have a webinar on June 14th. So Dave Graves, I believe, will be presenting that. So a lot of you in the Fusion area might know Dave. And so he'll be presenting on Fusion Simulation, the other option that you have available to you, on June 14th. You do have access to it today, so go ahead and start playing with that. And then for other important information, aside from that, is your call to action. If you want information, more information on Fusion, leverage the Autodesk employees, leverage your channel partners, and figure out how you can get moving with Fusion. If you have an interest in looking at In-CAD or having a discussion around In-CAD, contact your local reseller or your direct Autodesk sales rep, and we would be very glad to have a conversation with you. So with that being said, I want to thank you for joining today. And what I'm going to do is I'm going to open up the lines here so my other colleagues can join in, and I'm sure they've been busy answering questions in the Q&A panel. I'll open up the floor to them, and then I'll also let them address any questions they've been seeing in the window. But if you do hop off, I want to thank you for your time today.
Hello, Corey. This is Ryan Abel. Can you hear me okay?
Hey, Ryan.
Great presentation. And you're right. There's been a lot of questions coming in, and Mitch, Alan, and myself have been pretty busy. So we do have some time for you guys to enter more questions. And in the meantime, we will pick out a few here that we feel would definitely benefit the entire group.
Yep, and so we have Alan. Are you on here as well?
Yep, Corey, I'm on.
All right. You've been busy, I'm sure.
Just a tad.
Good, good.
Mitch, are you unmuted now?
Yeah, I'm here as well.
All right. So let's see. I'll pick one out. Let's see. There was one that I thought was pretty interesting, and I'll just read it here verbatim. And Alan, you did answer this one. So it was we currently use simulation, simulation mechanical, and also work in Inventor. Will Nastran have the user controls present in simulation versus what is currently in Inventor simulation? He goes on to explain, in the past they have done comparisons with FEA models with Inventor simulation, and they've noticed they had much less control over the model, for instance, where they can apply the load, and applying it to a specific node, for instance. And I thought you had a good answer here. Maybe you can expand on it for the group.
Yeah, I'll take that one, Mitch. Yeah, so in general, there's going to be a lot more controls for loads, boundary conditions, and meshing. Meshing, for example, you can not only change global mesh size, you can change mesh size per part through a meshing table. You can change mesh control through edges and surfaces, and also vertices and points. So you'll find generally for most types of selections, there's a lot more capability and a lot more types of selection. I think the other part of it that is also that since we're in CAD, we are geometry based. So instead of a node, you would just essentially select a point or vertex, but essentially that's pretty much the same thing. The result is the same on the FEA side. That's I think that's about it. All I got for that one.
Yeah, I was going to say, Alan, just to add, yeah, like you were just talking about it there at the end, right? If you want to create a node or a vertex, it's just different, right? So you just go in and you create if you have used a split command before, there's ways that we can leverage that to your advantage. If you want to focus in on a particular region. So let's say that you have like, I'm looking at my big desk in front of me right now, right? And so let's say I want to concentrate a load on a particular place on that desk. Well, all I have to do is split a particular region on that desk and then just refine it to that area. If it happens to be a particular node that I want to control, then I can just, like Alan said, create a vertex or a split to create that vertex. So there's ways of going about it. It's just different, but similar.
Okay, there's a few more questions that have come in. So let's see if we can't stay on top of those. And I have another one here, and this comes up often, and Mitch, you answered this one. Regards to the mesh, will brick type mesh be added for Nastran In-CAD? What other types of mesh types that we had in simulation mechanical will be added? This refers back to our solids are TET meshed in In-CAD, and some mechanical customers have a workflow of typically using brick meshes. Mitch, is that one you can elaborate on?
Yeah, definitely. So I think the supporting brick elements inside of In-CAD is still the #1 request on our idea station, and if anyone hasn't seen it yet, then Nastran In-CAD idea station is how we communicate with customers, get the feedback from them, and figure out what we want to do on the development side. And so I think it's still one of the biggest ones on there. I think the one that's holding us back from doing it is it's going to involve basically overhauling the entire mesher just to get that feature in there. And one of the things that's really holding it back is that the Nastran solver really does well with tetrahedral elements. And we've seen that technology grow quite a bit over the last couple of years, so that the tetrahedral elements perform quite a lot better than the hex ones. And you'll get for a similar size model, you'll get the tetrahedral elements will actually complete quite a bit faster. So there's a little bit of a gray area. We've been taught in school that hex elements are always going to be better than tets. You're going to get better results for fewer element count. But the thing that's changed over the last couple of years is the performance that we've got on specifically TET 10 elements. And so the balance is kind of right in the middle there. And the disadvantage that we have with the hex elements in a solid modeling environment is not everything is hex meshable. So hex meshes work really well for extruded parts, revolves and things like that. And when you get anything in between where there's some sort of thing that can't be hex meshed, you have to do a little bit of magic. And I know Simulation Mechanical had a very strong capability there where it would do hex elements on the outside, it'd do hex elements on the inside, and had transition elements in between. We've looked at it a little bit, seeing if we want to use that mesher, but we're still trying to figure out that perfect scenario. So it's something that we're investigating and we're listening to our customers, but for now we're going to stick with the TET elements.
Well, it sounds like taking another look at running your models in TET's worth it, and if you have more feedback, Mitch would like to hear from you and talk more about your application. There's another one. Do you have the similar abilities to set various load cases and load combinations as Sim Mechanical?
Yeah, that's one I was actually in the middle of replying to, so thank you for bringing that one up. Actually, the answer for that one is no. Simulation Mechanical has the ability to scale results after the analysis is completed. Now, in In-CAD, we do this a little bit differently. So you have the ability to set up all your subcases beforehand, and because it's the same model and all you're adjusting is the loads, Nastran actually cranks through all of those subcases very quickly, and so you'll have all the output for those subcases at the end. That's currently what it's doing. I know we are looking at expanding out on our post-processing capabilities a little bit, but especially when comparing what we have in SimMech, but that's the way we do it today.
Okay. Here's another one we haven't gotten around to answering yet, and this has come up a lot with myself, and we'll see who wants to take it, but what about having MES, which is mechanical event simulation? It was solver option, Sim Mechanical, that was very popular. What about having MES in In-CAD?
So MES, I'll take that one as well. So MES is a little bit of a tricky beast. MES kind of encompassed a lot of different things in simulation mechanical, from just nonlinear statics to nonlinear materials, transient dynamics, and I think one of the big differentiations that it had there was the ability to do kinematic elements. I don't know how many people are actually using that, but I think really being able to just take a part out of the model, treat it almost like a rigid element, and do some sort of a nonlinear transient kinematic solution. So InCAD has a nonlinear transient solution. It's not separate. We aren't calling it MES. We also have nonlinear statics. We have nonlinear materials and all those different capabilities. The one thing it doesn't have are those kinematic elements. So for now, with InCAD, you'd have to treat it as a fully deformable body. But you can do similar analyses like you would do in MES.
Right. This is a good example of the slide Corey showed, where a lot of the same functionality is in InCAD. It's just called different because it was built differently. And when you decouple all the MES functionalities, there's really only one thing that isn't in InCAD today. It doesn't mean you can't solve the problem. It's just not going to solve as quickly because you're not treating that one element or parts as the rigid kinematic parts. So that was a pretty unique solution in the industry, and it's something that development has their eyes on. So working with our sim team to find a workflow for all the other ways MES was used is what we're really focused on. That kinematic element is something we need to work on. All right, Mitch or Alan, was there a question you answered? There's a lot here for me to go through, but is there one that you answered that you'd like to share with the group?
I think probably one that's come up quite a few times, and I'd like to address it anyway, is that the transfer of SimMech data to InCAD. Currently, we do not have a translator from SimMech to InCAD. The only analysis import that we have for InCAD is to bring data from inventor stress. So if you have a inventor stress model that you've built, you can bring that across in InCAD and analyze it with InCAD. But we're currently investigating what we can do with SimMech data, so stay tuned for that.
Yeah, that's a big one, and just from not being disruptive and being able to reopen up your past workflow and progress, or just your results. And certainly if you have, I've seen some people here sharing specific cases, and they're very important for us, and keep those coming. I'll take one here because it came up with it was CFD related, and I like to use all simulation tools, but I've definitely spent most of my time in the CFD world. And it was looking for hull design, for complicated analysis like ship hull, propeller flow, how they interact. What do you suggest for FEA and CFD? And this is looking at a transient CFD run, and you're bringing it in. So you'll be running that with CFD motion because you want to see the propeller as it passes through the hull. You want to see how the forces and the pressures change on the hull. So in CFD, we can save all those time steps from that transient fluid motion interaction. And then Nastran In-CAD allows you to read in whatever time step you want to figure out what that loading scenario would look like. So CFD motion plus Nastran In-CAD, is the way to go. Certainly Fusion through its development path. Well, today Fusion does not offer a solution for that type of fluid structure interaction. Alan, do you see one in here that you would like to share with the group?
Yeah, I was just looking through the list here. I think there was a few questions about 2D planar analysis, and we do recognize there's some instances pressure vessels or other symmetric vessels where you know, it reduces runtime. So currently for 2D analyses, there's multiple types, right? We do 2D plane strain, and we do 2D plane stress. As far as 2D axis symmetric, it's in the solver, but not exposed to Nastran In-CAD yet. Definitely on the enhancement list, and they are usable for you know, different types of analysis, linear, nonlinear, and dynamics.
That's right, and that brings up another interesting point that there was a question, I can't find it right now, but asking about from a consulting group that does a lot of FEA validation runs, and you know, being built on top of the Nastran technology, and certainly Mitch or Alan, if you want to cut me off, go ahead. It builds quite a great ecosystem of you have a common file type. So we do have a standalone Nastran solver that has more capability than we've been able to put into Nastran In-CAD or Fusion yet. But it has created a really nice ecosystem where consultants can get more simulation done with Nastran In-CAD, and increase their license count, and really then pass that over and really use the full-blown analysis tool for final validation, or just for some of these advanced setup applications that haven't been integrated into our CAD-driven tools yet.
Yeah, right. I guess there's a few aspects of that, but yeah, one aspect of that is the connection to the Nastran community, or really any customer or client or partner that uses Nastran. And every time you run Nastran In-CAD, that Nastran file is created for you in your working folder, and that's something that other companies can take, run themselves, or bring into their own modelers or pre and post processors. It's an easy way to communicate.
Yeah, and it's been a lot. It's a lot easier. It's very easy to find people with Nastran experience, which is another big reason for us focusing on this technology, is the strength of the community, the strength of the user base, and finding talent to expand your teams becomes a lot easier. All right, we have 2 minutes left. Let's see if any other new questions came in that are worth expanding on. A few came in on pressure vessels. The question is, let's see. There was the ability to do pressure vessel design and pressure vessel simulation, and looking for stretch linearization. What options do they have moving forward?
Yeah, that's a little bit of a tricky one. So I think the messaging that we have around the end of sale of SimMech and In-CAD or Fusion or whatever makes sense kind of comes into play here. So if that is a needed feature, it's something that SimMech does a really good job of, and it's really dedicated to that pressure vessel design and analysis. If that's something you're using on a daily basis, you definitely want to keep using SimMech while you can. And that's the intention of this, is you can keep using SimMech as long as you have that license available. But if that's something that is not needed, then maybe looking at In-CAD or Fusion, it makes sense. I know from an In-CAD perspective, this is definitely something that we're investigating. We get a lot of questions about it, not just from SimMech customers as well. So we have a lot of customers working in this industry, and we're very interested in helping provide access to that. So stay tuned for that one as well.
Yeah, I'm even thinking about, I was doing some work with one of the new space companies, and they're designing pressure vessels with all different types of carbon fiber weaving designs. And I would encourage anybody on the call that uses the pressure vessel tool a lot to think, like Mitch said, that you can use that product and that functionality for as long as you need to. What we would be really interested in is understanding what the current solution doesn't provide you. How can we make it more valuable as we transition that type of technology to one of our new solution platforms. So with that, we've reached the top of the hour, and thanks for all the questions. Any of us are happy to hear from you guys, and we'll definitely help you through any transition or technical discussion that you might have. And if you all you need to do is put a dot between our first and last name and add Autodesk, and you got us. So with that, thank you.
Thanks, everybody.